edition of the Embedded Insiders, Brandon and Rich discuss how digital twins that reflect physical IoT systems can not only record the status of real-world devices, but simulate how the devices could react under certain conditions in the future, and how these twins can also potentially be used to help inform future designs. Later, the Insiders are joined by Brady Benware, VP and General Manager of the Tessent portfolio at Mentor, a Siemens business. The company recently acquired UltraSoC, who focuses on-chip analytics among other things, perhaps allowing Siemens to address the concept of digital twins all the way down to the chip level. After, John Labrosse is back with Things That Annoy a Veteran Software Engineer, where he explains why inconsistent use of acronyms and abbreviations bothers him.
Good afternoon, Rich Nass, Executive Vice President with Open Systems Media and leader of the Embedded Computing Design franchise, here with my co-leader, Brandon Lewis, for this week's Embedded Insiders. Hello, Brandon.
Hi, Rich. I wonder why is it always afternoon where you are?
Well, because I'm 3 hours ahead.
Well, you're 3 hours ahead of me, but here it's 8:30 in the morning.
Well, I get up so early that it feels like it's always near the end of my day.
Okay. We are in this world now where the Internet of Things has all of these sensors, all of these components, everything's connected, and we're starting to be able to do some really cool things with that data. Actually, we're not starting to, people have been. And one of the ways they've been doing that is by creating digital twins. Do you know what a digital twin is? I
do know what a digital twin is.
What is it?
It's when you replicate your system with a second system that is a digital version, a virtual as opposed to a physical system. And then you can do all your calculations, manipulations, whatever on that digital version. And presumably if it actually is a twin, you would have the same implications on the actual physical system that you had on the digital system.
Yeah, and one of the other things that's really profound about a digital twin is, in theory, you could manipulate, using your terminology, what would happen to that real life physical system under a bunch of different conditions out in the wild. So say it's a car, for example. What if this car, has 115,000 miles on it? It's running here in Arizona. You drive it out to, to Florida, where you are, and all of these different things are happening to it along the way. Now, one of the issues here is, how effective is a digital twin if you're modeling the entire vehicle, but not all of the specific components within that vehicle? I would assume it's not that effective, right?
Your example is a good one, and probably one of the most difficult ones, because there's so many factors that come into play that you're likely not aware of, that you wouldn't even think to simulate.
So a car, for example, has how many different components are there in a car?
Well, the last one that I just looked at had 150 ECUs on it.
Okay. So during that trip that we're talking about with this 115,000 mile car driving from Arizona to Florida, you're talking about looking at what's happening to all of those different ECUs over the course of that trip in this digital twin. And that's, it's just mountains and mountains of data. And actually, even further than that, what's happening inside of those ECUs, not how they're interacting with each other and how the corresponding subsystems are changing, what's happening down inside of the chip itself. And that's something that people over at Mentor, or Siemens business, actually have recognized could be very, very advantageous. And what they did to address it is acquire UltraSoC. Do you know who UltraSoC is?
I do know who UltraSoC is. I was first introduced to them when RISC-V came into vogue, but they actually go beyond RISC-V.
Yeah, for sure. One of the things that they do is this on-chip analytics, and over at Mentor, they're going to be looking at it in terms of sort of an EDA context, but it does have some pretty awesome implications for how you can look at what's happening down at the chip level, and then being part of a company like Siemens, that could really upstream out throughout the entire system of systems that is a car.
Rather than just you and I go back and forth about it, it'd be great if we had somebody from Siemens who could talk about it.
Wouldn't it? Brady Benware, VP and General Manager of the Tessent portfolio, is joining us next.
The Insiders are now joined by Brady Benware, VP and General Manager of the Tessent portfolio at Mentor, a Siemens business. He discusses the company's recent acquisition of UltraSoC.
So big news out of Mentor over the past couple of days is that Mentor, a Siemens business, and I guess Siemens in a broader sense, has acquired UltraSoC. For those listeners who aren't aware of UltraSoC, can you give us a little bit of background on the company?
Sure. UltraSoC is a UK-based company that works in the space of embedded analytics for SoC devices. They provide instrumentation within the device in order to really have a significant impact in the rest of the life cycle, from the debug phases in late stages of verification through first silicon, and then later on in through the end use of the devices in their in-life application in areas of providing capabilities to do monitoring of the devices for things like functional safety, security, and continuous device optimization.
So I know that UltraSoC has a pretty comprehensive portfolio, but specifically they've been doing a lot of work in the automotive space. Does that fit really well with what Mentor and Siemens in general are trying to go after? How does that going to fit into your portfolio serving those customers?
Yeah, that's a great question, and certainly this is a very exciting acquisition for us because of the nature of how well it fits into the overall strategy that we have within Siemens Digital Industry Software and within the EDA space in particular, where Mentor comes into the picture, and the area of the Tessent product family, which has traditionally served the design for test market. So that basic vision is that as we go forward here, companies are needing additional solutions in order to deal with the complexities of the complete product lifecycle. So it's no longer just about designing an SoC for its primary function, but then adding all of this instrumentation in there to really accelerate and be successful throughout the rest of the lifecycle. And that certainly includes areas like automotive, where functional safety is such a critical factor, and certainly within the digital industry software accelerator platform, there are a number of key capabilities that are serving the automotive industry today. And this is a nice complement not only to what we're doing in the area of design for test for automotive, but also the broader general strategy that's employed here in the accelerator portfolio.
One of the really compelling things about this acquisition to me is, as you've mentioned, Brady, you're talking about the ability in one portion of the UltraSoC portfolio to do this monitoring down at the chip level, which really speaks to this sort of industry 4.0 context of having these feedback loops that are continuously informing what's going on within components of a system. So do you see this plugging in? You mentioned the broader digital software offerings, plugging into sort of digital twin-like platforms that can be pushed out into various different sectors to, let's say, to monitor a robotics platform or to look at what an autonomous vehicle is doing over its life cycle?
Yeah, excellent point. Certainly this is a very natural component of the broader strategy associated with the digital twin, and really leveraging the knowledge that you build up in the design phase and the capabilities, that instrumentation, out throughout the rest of that life cycle into a lot of these interesting application areas. You mentioned robotics, autonomous drive, and those are very, very applicable areas where the ability to monitor what's going on in the device, leveraging that data, leveraging the insight there to not only drive those improvements and have that standalone protection for the device, but bringing that data out in a broader sense and understanding how to drive optimizations in the operation of those capabilities is a key component. I would add, though, that beyond the application areas that you mentioned, certainly one of the really large areas of interest is going to be in terms of the data center, where you start to bring together lots of different workloads, and the need to understand how those workloads are actually interacting with the hardware itself. Having that insight all the way down at the hardware level is going to create tremendous amount of opportunity to drive improvements in how that hardware is created, how the software is created, and ultimately how you structure those workloads within the data center. So a number of areas here where this is applicable really quite broadly across the industry as we get into the future here of AI, robotics, autonomous drive, and cloud operation for everything. It's going to have a widespread effect.
So with that said, how much of this acquisition is it so you can have UltraSoC as an internal customer as opposed to selling to the outside world?
Yeah, great question, Rich. The premise of this acquisition really is founded on the fact that we actually have a shared vision for what the industry needs and where it's headed. And so this is really all about serving external customers with a combined set of solutions that are very complementary, serving that same vision today. So this is not about having an internal customer as it is about serving the industry with complementary solutions that are really tackling those life cycle challenges that customers have today.
I'm pretty familiar with Siemens and with Mentor, and there's a lot of really smart people at these companies. Why didn't you just develop this technology in-house?
Yeah, great question. Certainly, this is an area where it's a very compelling area. And as we look at the strategy, we had a very specific intent to get into this area, and especially into the area of the functional monitoring to complement the structural capabilities that are there today. And certainly, as you look at the options that you have available to you, where you're doing build, buy, partner kinds of decisions, it became pretty obvious pretty quickly that the buy approach was definitely the right approach in this case. And it's not just because of the technologies and what you have to build. It's really about the experience of the team, the knowledge that they've built up over the last 5 years as they've accelerated into the space of in life, and as well the traction that they have with the customer base today, and the partnerships that they have. So certainly when you look at a decision like this, technology is and the building of the product is certainly one component. But when you bring together the experiences and the traction that already exists with UltraSoC, it made all the sense in the world that given that uniqueness that they possess in this area, that it made all the sense in the world to do an acquisition.
So Brady, if you were a Tessent user in the past, or you were an UltraSoC user in the past, how can you expect to see these technologies moving forward in the future? Are they going to be integrated all under the Tessent portfolio, or are they going to be kept separate? How's the integration going to work?
Yeah, great question. In terms of where these capabilities are being brought into the portfolio within this accelerator portfolio, it's being brought in tight integration with the Tessent product family. And so that has been traditionally a design for test portfolio of capabilities. But what we've seen within that area of design for test is a fairly rapid evolution and expansion of the responsibilities that design for test is serving today. And it's really that underlying motivating force here that where we're seeing the expansion in the role of test as it goes from really being part of a manufacturing operation to really serving the purposes throughout the entire life cycle, and especially that end use environment with functional safety. That's where we see a lot of similarity in terms of the nature of augmenting designs with these subsystems having the linked applications throughout the rest of the life cycle to leverage that instrumentation, and ultimately be a source of data for a lot of the analytics that are going to drive that success throughout the life cycle. That common basic approach to the solutions, but really solving complementary and different challenges with respect to the design for test technologies, which have largely been focused on things like defects and reliability, versus the UltraSoC technologies that are focused on more of a functional monitoring and can address some of the challenges associated with hardware bugs, software bugs, malicious attacks, and even surprises in terms of the use cases or workloads that are operating on these devices. These are really serving the same vision, but with very complementary technologies. And so we see that tight integration with the Tessent portfolio. But at the same time, it's really going to leverage the extent and the breadth of the scope of the digital industry software portfolio, and look at things like the broader set of capabilities for data analytics, and really making use of this throughout the full complement of the accelerator platform.
So we'd be remiss, Brady, if we didn't mention the fact that UltraSoC was one of the early members of the RISC-V Foundation. RISC-V is the open source ISA that's produced a lot of new startups and chips and some disruption in the industry. Does that have any? Does that play any role in this acquisition as Mentor and Siemens, in a broader perspective, looking into the RISC-V ISA and technology portfolio?
Yeah, RISC-V is certainly a very interesting area within the industry these days. It gets a lot of attention. And as you said, UltraSoC has made an investment in order to ensure that its products work very well with RISC-V processors. But it's worth noting that the technologies here and the capabilities support a very broad range of processors, whether those are ARM processors or MIPS or RISC-V or ARC. All of the processors are supported, and this is really about ensuring that we have the capabilities that are being used by our customers. So independent of what core they're using, that they have a single unified way of doing the monitoring across that, whether that's mix and matched or what variety they're using, that we want to make sure that we have solutions that are compatible with what they're choosing to use. And so certainly the investment in RISC-V is largely about the fact that it is a community that has to come together to develop standards, and where our investment is there, and where UltraSoC's investment there is ensuring that those standards are in place so that we can take these unified approaches to being able to monitor all of those processors, the buses that are on the devices, and any custom logic that's in there as well.
Now, John Labrosse is back with more Things That Annoy a Veteran Software Engineer.
So one of the things that irritates me is the inconsistent use of acronyms and abbreviations. So for example, instead of using the word average and spell it out in an identifier, I'd rather somebody standardize on AVG. It's pretty much understood by everybody that AVG stands for average. There's no need to spell it all out. Using the agreed upon acronym or abbreviation also saves a lot of time when you're actually searching for identifiers in one or multiple files. So instead of looking, I got to look for average, I got to look for AVG, I got to look for AVE, I got to look for all kinds of different ways you've decided to spell that. So with that being said, I hope that the team of developers are actually keeping track of all these agreed upon acronyms and abbreviations so that there is no confusion and that everybody agrees that they should be using all the same things.
Thanks for listening to this edition of Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.